Welcome. In this video, we will look at rotations, another transformation. So a rotation is a transformation that rotates each point in the pre-image about a center of rotation through the angle of rotation. Right? So here's a diagram. Here's what it looks like. So every single one of these points was rotated, right? If we have our pre-image here, and I can tell it's the pre-image because it does not have the primes, was rotated a certain number of degrees. And we'll look again at this diagram in a moment, but let's look at the notation, right? So this lowercase r means that it is a rotation, not to be confused with our uppercase R, which is a reflection. So next thing I want you to notice is the first thing that we're going to put in this little lower part of our notation in parentheses is the degree of the rotation. And then lastly, the information we need is the point that we're rotating around. And we can call that the center of rotation, right? And so it could be a coordinate pair, or it could be like in this picture here, how we have our points labeled, right? So we see that we are rotating around P. Okay, well, something that you should know when you accomplish a rotation is that PA is congruent to PA prime, meaning this point is going to be equal distance from the center of rotation in the pre-image as it is in the image. Okay, that distance hasn't changed. Just like PB, so for instance, I'm going to draw this in. PB, right, would be the same length as PB prime because the distance of this point from the center of rotation did not change. It moved over here, but it didn't get any closer or further away. And then finally, we would have our PC and PC prime, same deal here. Whoops, I drew that to the wrong spot. Here we go, PC prime and PC, right? Again, these are going to be the same length. That's what this is saying here, that the measures are equal, because this point C did not get further away from P or closer. All right, the next thing to notice is that these angles are all the same, right? And it's the degree of the rotation. So for instance, this angle, APA, there we go, I got rid of everything. APA, this angle right here, is some degree, right? And that degree, APA prime, is the same as the degree of BP B prime, right? That's going to be also x degree, whatever that is. And then of CP, C prime would also have the same degree. It's kind of messy there, and I also have that weird arrow that for some reason is frozen on the screen. Okay, but all those angles, it's going to, all the points have to rotate the exact same degree, so that way you actually get a rotation of the whole figure. Okay, let's see some rotations in action here. I don't know why this little arrow's over here. That's weird. Anyway, we're going to start by doing some basic rotations around the origin. Okay, so R, right, is for rotation. My angle of rotation, well, they're all multiples of 90. Okay, that's what makes them easy to kind of eyeball on the page here. So I'm going to go 90, 180, and then 270. Okay, and these are these are counterclockwise. Okay, because this is how the coordinate plane works. This is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. So when we say 90 degrees, we're going this way. Okay, about the origin, 0. Okay, so I put O for origin. Now, part of the reason why these are easy is because we can see, we can easily see it in the coordinate plane. It should be something that we can eyeball. And there's also a little trick once you learn it to the points. So if I wanted to rotate A, let me show you where we're going to go counterclockwise. Well, remember that this would be 90, this would be 180, this would be 270, this would be 360. So we're only going 90. So that puts our A prime right here. Get rid of this little circle here because we don't need that. Okay, so where would our C prime be, or where would our B prime be? Well, if I rotate it 90 degrees, there's my B prime there. And now C might be harder to rotate, but I can see, remember this is going to be an isometry, So that means that this length here is going to stay the same. And I can see that that's 1 unit. So I can just go 1 unit from B prime and say, okay, that's C prime. Okay, we can see that. That looks like the correct rotation. Now let's look at those points. Our original C was 3, 1, and now our C prime is negative 1, 3. So when I do a 90-degree rotation, what changed here? Well, my X and Y flipped, and then my new X became negative. So to show that in the notation up here, I would show that my X and Y flipped like this, and my new X, right, is negative. So if you're trying to perform a 90-degree rotation about the origin, you could just take all your points and apply this transformation to them. Switch the X and the Y, make the new X negative, and then plot all of them. All right, let's go ahead and try the 180 degree. So 180, if I'm starting here, I would have to go half a circle away. So now go ahead and pause the video and see if you can come up with the rest of those points on your own. So rotate C and B 180 degrees and see where they land. Okay, did you get this image? If you did, good job. Now let's figure out what happens to XY. Okay, and I'm looking at C because if you look at, or how C changes to C prime, because if you look at B and B prime, the only issue there is that we have a value of 0, right? So this is 3, 0, so we can't tell if the negative changed. So look at C and C prime. Well, this was 3, 1, and now it's negative 3, negative 1. So how would you write that? Go ahead and fill that in here. We still have a 3 for the X, and we still have a 1 for the Y, but now we have the opposite signs. So we would write that like this. All right, now try to do the rotation of 270 degrees about the origin. Again, pause the video, come up with that rotation, and see if you can also figure out what's happening to the X and Y values when you do that by looking at how C changed. Okay, hopefully you got this picture here, right, with your C on this side, not over here. That would be incorrect, but over here. And then we can see that our X and Y flip, and it is the new Y that gets the negative. Okay, now we're going to rotate around a point other than the origin. Okay, so for this notation here we're doing a rotation of 270 degrees about A, right? So we have to look in our picture, find A, that's what we're going to rotate around. So if I'm rotating around A, point A and A prime are going to be in the same spot. All right, so here's my A prime. Okay, now let's rotate our B all the way around. So we're going to end up down here, right? Oh, no, I went too far, but that's good. So you can see that you can make a mistake there. And the reason I caught it is it needs to be 2 away from A, right? And I went 3 away down there. So there's 2 away. Okay, now I need to think about where my C is going to be in relationship to my B. Well, it needs to go out this way. And there we go. And now, to make sure that I've done this correctly, I'm going to look, well, are all the sides the same length and all the angle measures the same length? Well, it does look like AB is 2 units, or sorry, A prime, B prime, and AB are 2 units. And then I have 1 unit here, 1 unit here, so that looks right. And then this, I would have to do the Pythagorean theorem to figure out how long this is, but I can kind of see that I'm going diagonally across 2 boxes, so that looks correct. All right, so what happened to C here? Let's see. It went from 3, 1 to 2, negative 2. Okay, so no apparent pattern here. So this is a little bit harder to pull off because unlike this one about the origin, right, when we go about the origin, we can just rearrange our X and Y, and sometimes we make something negative
Down here, depending on what you go around, what the point is that you rotate around, you're going to get different values. So there's not a specific pattern that you can follow. Okay, give these next two a try. See if you could eyeball this one, right? So we're going around B, 90 degrees. Remember, we always go in the counterclockwise direction, so this way. So B's not going to move, the rest of it's going to move around it. And then we're going to go around C, 180 degrees, so C up here. Okay, so pause the video, try to perform these rotations. It's okay if you mess up, and just see if you can come up with them. Okay, here are my two other rotations here. I did a 90 degree about B, right? And I decided that my new point 3, 1, my new C prime, C double prime, was at 3, 1, is now at 2, 0. And then for this last one, I went 180 degrees, right? And ended up with a double or triple prime over here, but the C is in the exact same spot. So the one easy point to find when you're doing a rotation about a point other than the origin is the point that you're rotating around, right? That one's going to stay the same, but there's no pattern for the rest. And so you would have to actually perform the rotation to figure out where all your points lie. However, remember that it should have, if you were to connect the points through the rotation point, they should all have the same angle. So I'm going to make my drawing here kind of messy, but let's look at that here, right? So for instance, if I were to connect C to my C double prime, right? If I did a rotation of 90 degrees, that should create a 90 degree angle there. And that does look like a 90 degree angle. Now let's do that with A, right? So if I were to connect A through my rotation point to my A prime, I should have a 90 degree angle, and I do see that. So that's a way to check, and let's go ahead and check for my 180 degrees. If I were to connect my A to my A triple prime, it should be a 180 degree angle if I go right through my rotation point C, right? That's what happened there. If I connect my B through my rotation point C, right there, to my B triple prime, it should be 180 degrees. And that is what I'm seeing. So that brings us rotations of other angle measures. So let's say I wanted to do a rotation of, let's go with 30 degrees around some point P, right, of triangle ABC. So I'm just going to draw a triangle over here and call it ABC. And then I'm going to pick some place and call this P. Okay, and now I'm going to rotate this triangle about P 30 degrees. And actually, I'm going to make this a bigger angle just because I want it to rotate off of it so I can clearly see what I'm doing here. So let's go with like 110, right? So that's bigger than 90. So if I want to do this, I would have to get out a ruler and a protractor, even if it was on the coordinate plane, and I'd have to make a bunch of angles that are all 110 degrees. So I would start by connecting P to C with a straight edge, and then I would want to create an angle using a protractor that's 110 degrees, right? So I'm eyeballing it right now, but if I were doing this for real, for instance on a project, I would want to come up with I would want to use a protractor and come up with an angle that is 110 degrees. Now, also, it has to be the same length. So this PC would have to be the same length as PC prime. And I would want to use a ruler to do that, right? Because it would have to be the same distance from P. Then I would do the same for A. I'd connect A to P. Then I would use a protractor, and I would draw that angle, which would also have to be 110 degrees, and also the same length as AP, right? These don't have to be the same length, but A has to be the same distance from P as A double prime. Okay, and if I connect these two, connect it with a different color, right? I should have, I'm not going to complete the triangle just to keep this a little bit shorter, but I should have a rotation now of this line 110 degrees. Now, because I eyeballed it, I would not say that this is perfect. You would have to use a ruler and a protractor to accomplish this correctly, but I want you to understand how that rotation would be if we weren't going one of these angles, multiples of 90, right? Doing multiples of 90 on a grid makes it a lot easier than going with an angle measure that's not a multiple of 90. Okay, one last thing I want to show you here is what happens if I do a composition of two reflections, right? Now I'm back on reflections here, but there's a reason. Because two reflections will give me a rotation. So composition of two reflections is going to give me a rotation. So let's draw a little picture here. Go ahead and pause and get this picture on your piece of paper. And when you're ready, start it up again. All right, so I've drawn this triangle and I've given myself two lines that are intersecting this time, right? They're not parallel. So it's a composition of two reflections, but reflections over lines that are not parallel, okay? So I've drawn this so that this is a 90-degree angle, okay, close enough. I'm kind of, again, eyeballing here. And I'm gonna perform the following reflection, okay? So I'm gonna reflect over line L, because remember we're gonna do this one first. And then we're going to put that reflection in this one, so then I reflect over line M. Okay, so I did big R, so that way I know that it's a reflection, not a rotation. And then I want to see what happens when I do that. What do I get? What final transformation do I get? Is it still a reflection? All right, so I want to go equal distance from my reflection line, or sorry, from my original point across my reflection line perpendicularly. I'm going to pause and try to sketch this out. See if you can pause and eyeball it yourself. Okay, so here's my first reflection, whoops, over line L. Okay, now I'm going to do this again over line M. So again, pause, see if you can get that reflection done correctly. Okay, here's what I came up with. Hopefully you came close. Okay, so now let's look and see where all these points landed compared to my original, right? So I have my B, well, I have my A right here, right? Let's call this intersection point, point P. Okay, so if my intersection point is point P, and I have my A here and my A double prime here, how do they relate? Well, just looking at those, I can't tell a whole lot, but let's see how the C's relate, right? So this A to C is going this way, this A to C is going that way. Well, this is actually a rotation. Let's put that in our notation up here. We did end up with a rotation, so lowercase r, but how many degrees and around what point? Okay, well, let me show you. We are going, if I were to connect A through point P to A prime, and I were to connect C through point P to C prime, and B, right? Those lines aren't very straight, but pretend that they are. This is a rotation of 180 degrees, right? Those are all 180 degree angles, and we rotated around point P. Okay, so when we have two reflections over a line, over two lines that are not parallel, that actually intersect, then we end up with a rotation. And that rotation angle is double the angle of intersection. Okay, so in words, a composition of two reflections over intersecting lines is a rotation. The angle of rotation is double the intersection angle. All right, that was a lot of stuff. Thanks for hanging in there for the whole thing, and I will see you in class.